Big thanks to 80,000 Hours for sponsoring this video.
Over the years, many physicists have been confident that physics is almost complete, and that humanity was just a small number of discoveries away from understanding everything in the universe. Usually though, this confidence has been relatively short-lived, as it came right before a new discovery or leap in understanding that completely turned everything on its head and opened up brand new areas of physics. What do you think? Will physics ever be complete? Hello there, my name is Parth. Now here's the thing. The aim of physics, broadly speaking, is to understand all of the phenomena that occur in the entire universe that we exist in and accurately predict what would happen in any given scenario that we can think of using our understanding of the universe. There are already lots of wonderful discussions on YouTube about all of the current big problems that need to be solved before physics is complete. How to unite gravity with the other three fundamental forces for a theory of everything, why there seems to be so much dark matter and dark energy in the universe, why normal matter outweighs antimatter, and so on. In addition to this, people have often talked about how confident scientists were about the state of physics, and then something huge like special relativity or quantum mechanics came around to humble us and make us realize we didn't know nearly as much as we thought we did. In this video though, I want to share with you a little story. A cautionary tale perhaps, about taking our knowledge and understanding of any subject for granted. Let's begin by looking at a single atom. Now, many of us might know that an atom consists of protons and neutrons forming the nucleus at the center, and then electrons being found in orbitals or energy levels around the nucleus. When this model of the atom was first proposed, it was also believed that electrons actually orbit around the nucleus like planets orbit a star. Fairly neat symmetry between the very small and the very large. And in fact, some schools still teach students that electrons orbit the nucleus when they first discuss atomic structure. Nowadays though, we don't think this is exactly how electrons behave. There's a quantum mechanical model of the atom that goes into all sorts of weird fuzziness, such as a cloud of probability where electrons could be found. We won't worry too much about that here. I've made lots of videos discussing that on this channel already, so you can check one of them out up here, or I'll link them in the description box as well. The really important idea we want to focus on is that electrons have different amounts of energy depending on which energy level they are found in. That's why these things are called energy levels. Electrons in the levels closer to the nucleus have less energy, and electrons further away have more energy, basically. Free electrons, meaning ones that are not bound to the atom or have been freed from it, have the most energy. If we started with just a nucleus and tried to build this atom up by adding electrons, the first electrons would go to the lowest available energy levels. Then the higher ones would fill up as the lower ones became full. This happens because generally, things in the universe tend towards lower energy configurations. So the lowest possible energy level would usually be the one that gets filled first. This is the basic yet key idea that we care about in this video. Now, for simplicity, we'll stop drawing these energy levels as circles and instead just draw them as straight lines. The lower ones are lower in energy and the higher ones are higher in energy. Simple as that. Now, we're not so worried at the moment about why different energy levels can fit in different numbers of electrons. More info in the description box below if you'd like to find out though. For some time, we thought that this was it. Atoms behaved like this. N equals 1 had the lowest energy and was filled first, then N equals 2, and so on and so forth. Until we actually saw how electrons filled up the shells of certain atoms. In some cases, electron shells that we thought were lower in energy got partially filled, then the next one up started filling up, and then this lower one finished filling up before we continued with the rest. What? Sorry, what? Well, it turned out that energy levels and electron shells weren't technically the exact same thing. Electron shells, which had to do with where in space electrons would be found around a nucleus, were split into different energy levels.
Before we look at this in more detail though, I want to take a moment to talk about the sponsor of this video, 80,000 Hours. Now, they're rather interesting because they're not actually selling anything. I'm genuinely really pleased to be working with them, and here's why. I've received many messages from you all asking about career options and advice on what to do in life. And what I consistently see in your messages to me is that all of you want to make a difference. All of you are looking to make a positive impact in some way or to help solve the world's biggest problems. And this is where 80,000 Hours comes into the picture. They're a non-profit that aims to help people have a positive impact with their career. On average, each of us will spend 80,000 hours in our life working. That's 40 hours a week for 50 weeks a year for 40 years. That's a lot of time that could be spent doing good. So, 80,000 Hours offers a bunch of free services that can help you move your career in a direction that would be beneficial to humanity, like fighting climate change, or working on AI safety and policy, or focusing on global health and poverty, and many more other areas like this. They want to help you find a fulfilling career that also does good. And all of the services and advice offered by 80,000 Hours is backed by years of research conducted alongside academics from Oxford University. So at this point you might ask, what services do 80,000 Hours actually offer? Well, first of all, they have a website, 80,000hours.org, where they keep all of their research and guides about how to have a high-impact career. Definitely check that out. They also have a job board, which is regularly updated with hundreds of job openings for careers that will make a positive impact on the world. They have a podcast as well, where they have in-depth discussions with experts working on the world's biggest problems, and they talk about what you can do to help. And they have lots more stuff, remember, all free of charge. If you're trying to figure out what to do with your career, then please head over to 80,000hours.org/path in order to be sent a free copy of their in-depth career guide. This guide discusses what actually makes a high-impact career, gives you new ideas for impactful paths, and shows you how to plan your future and put it into action. Using the link also signs you up to their newsletter, from which you can unsubscribe with one click if you want to. But the newsletter is great because it contains updates about 80,000 Hours' latest research and latest job opportunities. Like I say, I'm genuinely happy to be working with 80,000 Hours. Please do check out all they have to offer. Click the link in the description below if you're interested in finding out more. Thank you once again to 80,000 Hours.
Now, let's get back to our electron shells, which we realized were split up into closely separated energy levels. The n is equal to 1 shell only contained 2 electrons and was genuinely a single energy level. But we realized that the n equals 2 shell was actually made up of a couple of different energy levels. The difference in energy between these levels was actually quite small, at least much smaller than the difference in energies between the gross structure energy levels. As we looked at higher and higher numbered shells, we realized that they were split into more and more energy levels. And occasionally, there would be an overlap between, say, the highest energy level in n equals 3 and the lowest energy level in n equals 4. Now, all of this is heavily oversimplified, but we can get the gist of the idea from this description. However, the idea that electrons filled the lowest energy levels first still remained strong. It's just that the arrangement of energy levels wasn't as simple as we initially thought. We've also verified these things with experiment, right? So we know experimentally that these things seem to be true, and it matches what the theory predicts. Great. The picture of the atom is a bit more complicated than we initially realized, but no big deal, right? Wrong. Yes, this is a big deal. Because actually, these energy levels are further split into even more energy levels. Once again, the splitting between these energy levels is quite small in energy, and that's why we didn't detect this much smaller splitting when we first realized that the fine structure splitting existed. Our instruments weren't good enough. We just thought that all of these electrons were in the same energy level. As our experimental methods and devices improved, we got a bit more clarity and realized that there is actually some splitting at this level too. We also understand now why this splitting happens. But what if there are other effects that cause an even smaller splitting? Does this keep on going forever? Or will we ever reach the end of these levels of splitting that get smaller and smaller each time? How much will we have to improve our measurement devices to know which is right? Who knows? The point of this story is to show that in the past we've dealt with scenarios where we thought we understood something quite well, and then realized that there were some fine details that we missed. And then we realized that there was yet another level of fine detail as well, and we don't yet know whether there are even finer details to look for. This shows that there is more to physics than we realize, even if we just consider the physics that we already know and understand. Basically, I'm not even talking about a brand new theory that changes the face of physics, like the advent of relativity and quantum mechanics did. I'm talking about when we knew about quantum mechanics and a lot of different effects from quantum mechanics, and we still didn't realize the level of complexity to which we could go. Now, I know that all of this is not actually evidence for physics continuing on forever and ever. After all, just because something has happened fairly consistently in the past doesn't mean it will continue to be like that. But either way, I wanted to tell you this rather interesting story. I hope you enjoyed it. If you did, please hit the thumbs up button, subscribe, and hit that bell button for more fun physics content. Check out my merch linked in the description box below. It features a quantum dice design based on a famous quote from Albert Einstein. And finally, a huge thank you to all of my Giga patrons and all of the others over on my Patreon page. That's also linked in the description box if you'd like to support me on there. Thank you so much for watching, and I will see you very soon.